Good day, viewers. My name is Samuel Atta. We are here once again to talk about logarithm, and we want to continue from where we stopped. And if you were in the previous lecture, you will discover we have touched some important questions, beginning from the laws of logarithm, and then also looking at the simplification in logarithm, and we attempted some questions. But today, we want to take it a little bit higher to talk about logarithmic equation. Check the board. You see logarithmic equation. That is equation in logarithm. So we will go straight into lectures without wasting time. All right. I have questions for you from your SSC exams, and possibly you can also attempt it in your UTME exams. Okay, the first question is from NECO 2004. NECO 2004. It says solve for x in the equation. Solve for x in the equation. So you are looking for x in this equation. You have the equation log x raised to the power 4 base 2 plus logarithm x base 2 equals 5. This question, we are supposed to arrive at an answer which is 2. Okay, so let's see how it goes. Now, don't forget the principles of logarithm that we learned in the previous lectures. And what was that principle? That when we are adding in logarithm, that we multiply when they are in the same base. Okay, so from what you have, you see that you have base 2 here, you also have base 2 here. So what you're going to do now is to take either of this side, the left hand side of the equation, and place it in base 2. Okay, and then what into this side, let's see, we have logarithm 2. I'm taking one of the log base 2, and then this logarithm x raised to the power 4, this particular logarithm x to the power 4 should be multiplied with this. Why? Because you are adding in the logarithm. So log 2 open bracket x dot x. When I say dot, I mean times. And don't forget that there's a power 1 here. Okay? So let me leave it there. Alright. So it's equal to 5. Now check this. What can you see here? So we have this particular equation with us. So check this side, you have what? What do you have on this side? How can you make this side, converting this logarithm into indices? What do? So now don't forget what I said. Log 1 base A is 0. Or you can say log 1 to any base is 0. We can easily convert this thing. So this format and this format is the same. And then this, how you go about it. Follow the arrow. This into this. So what it's trying to say is this, that a raised to the power of 0 is equal to 1. I repeat, a raised to the power of 0 is equal to 1. Alright? A raised to the power of 0 equal to 1. What do you have? That gives you a raised to the power of 0 equal to 1. This equation you're going to have. That means this equation is no longer logarithm, but it's now indices. And it's easier for you to solve. So what do? Now, work this here now. So, if I want to do the same thing, I say 2 raised to the power 5 equal to the logarithm. What logarithm I have now is x raised to the power 4 times x to the power 1. So, if you want to work this out, what do you have? So, let's take it now. Say 2 raised to the power 5 is equal to x raised to the power 4 dot raised to the power 1. So, that's it. Now let us do some work together. So 2 raised to the power 5 is equal to x. What is int telling you? That when you multiply the same base, you multiply, you take one of the base and you add the power. That's 4 plus 1. You have 5 here. So you see that at the end of the day, discover something, that the base is different, the base is different, 2x is different, but the power is the same. So what do? You equate the base and you eliminate the power. So when this 5 eliminates 5, your answer x becomes 2. Is that simple actually? Yes, very simple. But let's consider YX questions 2000. YX 2000, look at this here. y 2000. What it's saying, it said, given that 8 raised to power, given that 8 raised to power y all over 4, okay, is equal to logarithm 16 base 2. Mind you, we have multiple questions to solve, so, but this is not all there is. Okay, we have a lot of questions to solve, but let's go on. I look at this thing very well, and I check 16 and 2. I can place 16 and in an index, okay, using 2. So, and 16 is equal as 2 raised to the power of 4. We have 2 times 2, 4, 2 times 2 again, times 4 is 8, then another times 2 again gives you 16, that's raised to the power 4. So what we have now, we say 8 raised to the power y over 4 is equal to logarithm 2 raised to the power 4 base 2. And you know what happens? This logarithm, the power of the logarithm goes back to multiply the logarithm. So, okay, so 8 raised to the power y over 4, 4 goes back, becomes 4 logarithm 2 base 2. Of course, you know that every logarithm to its own base is 1, so log 2 base 2 is 1, and 1 times 4 gives us 4. So what you're going to have here is 8 raised to the power y over 4 equals to 4. Okay, and then you place both of them in index. 8 can be placed in index of 2, 4 can be placed in index of 2. You can't place 8 in index of index of base 4 raised to the power anything. So 4 raised to the power nothing will give you 8. Okay, you cannot say 4 raised to the power 2 to give you 8. It's not possible. 4 raised to the power 3 cannot give you 8. So you have to break 2 of them down to give you the proper index. So I said 2 raised to the power 3 is 8. So I'm putting under base 2. Then close the bracket. We have power here already, y over 4. Okay, then equal to 2 raised to the power of 2. So it's balanced now. So at this junction, understand that in index the power inside multiplied the power outside. So you're going to have 3 multiplying y, that's 3y over 4. Okay, mind you, if you have 2 over 3 multiplied by 4, this 4 multiplies 2, not the 3. So 4 times 2 give you 8 over 3. It always multiplies the numerator and not the denominator. So the 3 multiplies y will give you 2 raised to the power 3y over 4 equal to 2 raised to the power 2. At this junction, the first question we solved, we discovered that go back, you see that the power this time is the same, so I deleted the powers and then I equated the base. But right now, you see that the base is the same, 2, 2. So what do? You take the base away and then you work with the power. What's the power now? 3y over 4 equals 2 over 1. Cross multiply. 1 times 3y gives you 3y, and 4 times 2 gives you 8. And at the end of the day, what do? Divide both sides by the coefficient of y, which is 3. Then when 3 divided 3 is gone, bring down your y, then 8 divided 3. So this is the final answer you have. Alright, that's not all. We are going further to look at GC question year 1999. So I've taken the NECO, this is y, this is GC. So they are all the same principles to apply. Now there's a question for us here, of which if we solve it, we're supposed to arrive at 1 all over 8. So what do? Let me attempt that question. Given that log x base 2 plus 81, log 81 base 3 is equal to 1. What do we have? Please mind you, check this very well. We have log x base 2 plus logarithm. Let us see 3 raised to the power. What will give us any value here? Let's check it out. So we have 3 raised to the power. 3 times 3 is 9 times 3 is 27. So let's go again. 27 times another 3. Let's see what we have. Now 3 times 7 is what? 21. Rather 1 carry 2. This will give you what? 6. That's 8. That gives you 81. So that means you can place 81 in base 3 raised to power a number. That gives you log 3 raised to power 4 base 3 equals 1. Okay, now work it out again. You have log x base 2. This 4 goes back plus 4 log 3 base 3 equals 1. At the end of the day, discover that log 3 base 3 is 1, which multiplies 4 to give you 1 times 4, that's 4. You have log x base 2 plus 4 equals 1. So at the end of the day, what do? This plus 4 goes to the right hand side to make the equation balance. This is number and here is the number. So you say log x base 2 equals 1 minus 4. You have log x base 2 equals minus 3. So at this junction, what we do, quickly convert this thing to indices. I know the process. 2 raised to the power minus 3 equal to x. Please always follow this principle. That's how you go about it. Converting logarithm to indices is just a simple way like this. So what do you say? We'll say 2 raised to the power minus 3 is equal to x. Or you can go the other way to say x is equal to 2 raised to the power minus 3. Same thing. Then you have to convert your indices to this most standard way. Remove the minus sign. You have 1 all over 2 raised to the power 3. At the end of the day, you have 1 all over 8. You see? So we have arrived at the final answer. Okay. So we have a question here for us. I would like to go back to look at that question carefully. So now check this question before we think of moving on. We have logarithm, NECO 2005, very important question. NECO 2005 says log A, all in brackets, 5x minus 6 plus logarithm bracket 2x plus 3 base A equals to logarithm. We have logarithm 10 in bracket 10x squared minus 3x minus 5 base A. Please check. This equation is not balanced. Is it balanced? No. Why is it not balanced? It's not balanced because on the left hand side of the equation we have 2 logarithm. On the right hand side you just have only 1 logarithm. So what do you do to make it balanced? Simply work together, multiply this logarithm together. Why? Because you are adding. Of course they are the same base, so it's very easy to do so. So what do you say? On the left hand side we'll take only 1 logarithm A and then multiply this by this. So that gives us in brackets 5x minus 6 into 2x plus 3. So this is done. Then equal to logarithm into 10x squared minus 3x minus 5 base A. So it's balanced. Now that you have 1 logarithm on the left hand side, 1 logarithm on the right hand side, log A cancel log A. Okay, so when log A cancel log A, what do you have? A straight equation. So you have 5x minus 6 as against 2x plus 3 equals to 10x squared minus 3x minus 5. Okay, so we can move this out now. Alright, let's quickly expand the work. Can we expand the work? 5x multiply this, of course you know 5 times 2 is 10. Then x into it, that's x squared. We're not done with this. 5x again, we multiply 3, that's plus what? 3 times 5, that's 15x. We're done. Then take minus 6. Minus 6 multiplies this. Minus 6 times 2 is minus 12. Bring down the x. There's x here. This one doesn't have any s. Okay, so minus 6 again multiplies plus 3. So minus times this plus is minus. 3 times this 6 is 18. Done. Then, of course, there's nothing here to expand this bracket. So you just naturally open the bracket. So equal to 10x squared minus 3x minus 5. Now, at this junction, we want to bring all the x according to their power to the left hand side. Now, this has 10x squared. This has 10x squared here. Now, to make it very simple, let me show you something. When you have two quantities, two the same quantities on either side of the equation, you have two the same quantities on the left side and on the right side of the equation. Not only that, and the sign behind the quantity is also the same. They will naturally cancel out. Naturally. Let me show you what I'm trying to say. If you have something like 2x minus 4 is equal to 5 plus 2x. Now understand something here. This is an equation now. This is the left hand side of the equation, this is the right hand side of the equation. Now when you look at the left hand side, you're going to see 2x here. And what sign do you have on the back? Plus. The reason why the sign is not showing because there's no quantity, like a number or a letter, come before it. So we don't show the sign. We only show minus sign. Okay, now there's plus sign here, then that's left hand side. Then we check the right hand side, it's called that there's what? A plus sign again. Now the signs are the same. Naturally, in mathematics, naturally you cancel out easily. I'm just taking this as an example, please, mind you. So the same thing we can do here. Now check. There's 10x squared here. What sign you have here? Plus. There is 10x squared here. What sign you have here? Plus. Naturally, in mathematics, it cancels out. And then at the junction, you cannot bring all the x to one side. Now, what you have here now? You have 15x followed by the what? Minus what? 12x. Then you have minus 3x, which crosses the equality sign to become what? Plus 3x. Done. Then go to the numbers now. You already have minus 5 here, which will bring equal to minus 5. Then this plus minus 18 will cross over to give you plus 18. It's balanced. So let's just go from here now. When you subtract 12x from 15x, 15x minus 12x, of course you're going to get 3x. Okay? Then 3x plus this 3x, that gives you 6x. Then you go minus 5 plus 18, what do you get? Remove 5 from 18, what do you get? You get 13. Then, of course, what's next to do? You want to divide both sides by the quotient of x, which is 6. So x, when you see divide 6 is 0, it's gone. That's 1. Then you have 13 divided by 6. You can leave your answer here or put it in fractions. 6 can go into this two ways. 2 whole number, 1 all over 6. Then I leave your answer here or the rest of the case. So that's what we have here, 13 all over 6. You can see we have already solved these questions that seem kind of difficult for students to handle. So follow these principles down the line in turning point. We will show you step by step how to answer these questions. Alright, I did say that I promised that we are going to take more questions, and then the questions we had initially was questions from SSC, NECO and WAEC. But check the board, you will see questions on JAM. So I have JAM the year 1989, we have JAM question 1993, we have JAM questions 1999, and JAM questions 2004, and here we have 1992. So that if you are attempting the university tertiary matriculation examination, that UTME, you will be able, you should be able to get to that level where you see some little variation, and then you have to solve them. Because the questions sometimes a little bit tricky. So let's see how we can attempt their questions. Now, take the first one quickly. Say find P in terms of Q. Find P in terms of Q. Please, that statement before we start. That statement says find P in terms of Q means at the end of the day, you are going to make P subject of the formula. Okay? So bring the question now. We have log P is 3 plus 3 log cube is 3 equal to 3. It's okay. So this is the question we have. So if you want to solve this, please mind you, I place the answer by the corner. So you see 3 over cube raised to power 3. Let's see how we can answer this. Well, let's go quickly. So we have the question here before us, solution. It would be nice if you take this 3 back as a power, of course, because they're the same base. So this 3 should go as a power because you have, say, 2 log 2 log 3 base 5. It can also be written as 3 log 3 raised to power 2 base 5. So this 2 is going back. And if they give you like this in exam, so it would be nice if you write it like this to go back. 2 log 3 base 5. Please, you're bringing back the power, the coefficient of logarithm as a power, return it as a coefficient, depends on the question itself and what you want to use to do. So I'm bringing this coefficient of logarithm now as a power. Okay, I'm bringing it as a power because I want to multiply these two together. Alright, so we have logarithm P base 3 plus this 3 goes as a power now because logarithm, that's log Q by 3 base 3 is equal to 3. I think that's okay for now. And then at this junction, we want to quickly do the multiplication. Now base 3, means that you will take one of the logarithm, base 3, and then these two multiplies, that's pq raised to the power 3 equal to 3. I believe that at this junction you have already learned how to quickly convert from logarithm to indices. Okay, you know what I taught to you. Okay, what we discussed. Say take the logarithm 3 raised to the power 3 equal to, sorry, the base rather, 3 raised to the power 3 equal to the logarithm. That's how you convert. So let's go there. So if I say 3 raised to the power 3 is equal to pq q, that will be okay. So at this junction, what do you do? It says find p in terms of q. So make p subject of the formula. Of course, the only way you can get this p as subject, you have to remove the q raised to the power 3. So you have to divide the left hand side by this quantity here. So that's 3 cubed, which is already 27, divided by q raised to the power 3 is equal to p q raised to the power 3 divided by q raised to the power 3. Why am I doing this? I'm doing this because I need just p. So this q raised to the power 3 should go away. So the only way to do that is to divide both sides, right? So this cancels off p on one side now. Therefore p is equal to this quantity. P is equal to this quantity. That's p is equal to 27 all over q raised to the power 3. Mind you, this 27 was gotten from this. So if you want to take it back to make it good, this is supposed to be the answer. But just to make it match with what I have here as 3 raised over q raised to the power 3 means that you have to take the index again, 3 raised to the power 3. Of course, you know it came from here. So take it back, you now have q cubed. Now two of them have the same power. That means you can enclose them in a bracket and put one outside. So you can see 3 all over q raised to the power 3. So that's why it's that p now has been resolved in terms of q, made subject of the formula. That's the first question we have here. Okay, and I believe you are getting value. So let's quickly go to the next question. In UTME 1993, the same process, okay, but different formats here. We're having 2 log y base 3 plus log x base 2 raised to the power 3 equals 4. Now from what you have, it's very okay. So it's very nice now. You understand what I'm trying to say? That you should take this 2, of course, and take it as a power, of course. And how do you want to write that? You want to write it as log y raised to the power 2 base 3 plus logarithm x power 2 base 3 equals 4. I think this is very nice now. So you see, we already know what I'm talking about now. You know what to do next, right? Okay, so you just quickly say, oh, it's the same logarithm, just okay, fine. Logarithm 3, are you with me? Good. So then this multiplies this. This multiplies this. You know you're going to have x squared, y squared. Of course, they're carrying square, so what are you waiting for? Why don't you just say xy and close it and put one outside? It's the same thing. So now you're getting me now. Okay, so I think you're getting me. So y squared x squared, okay, equals 4. So what are you waiting for? Of course, 3 as usual raised to the power 4, right, equal to this. So let's go now. 3 raised to the power 4 is equal to this, which is same thing as y squared x squared, and which is 3 raised to the power 4 will give you what? 3 times 3 times 3, 27, times 3 again. That gives you 81. Okay, 81 is equal to x, xy. Let me just take alphabetical order. That's xy all squared. I think it's okay like this. Okay, so let's see. They said to find the value of y. So what should I do? Simple. To get the value of y, you have to quickly remove this square. So the bracket can go away. But what's remove square? The only thing that removes square is square root. So take square root of this, take square root of this. Now, if you're taking x squared, you're taking the square root of everything, you know that this square will what? Disannul this square root. So you're going to have xy left at the end of the day. Okay, so let's apply. So what do you have? You have the square root of 81 and this. Let me just show it out, okay? So xy all squared. Now watch. this is equal to 1, I'm going to have 9. Or you can say plus or minus 9 because it's coming from what? Root sign. So then this cancel this. You have what? xy. Of course. At the end of the day, you know we're almost done with this match. Okay. Now what I'm trying to say is this: to make y squared formula now, or to get the value of y, you have to eliminate this x using it to divide both sides. Are you with me now? So you see, at the end of the day, I have plus or minus 9 over x is equal to x y over x. So cancel off. Your y becomes, of course, the plus or minus the 9 all over x. I think that's what you have here. Result. Right? Result. Okay. Check this next question, please. I think you should be okay with this by now. So I want to wipe it off. So now let's see quickly. Let's see what we have. Bring forth that question. We have UTME, the year 1999. Okay. Now, what it's trying to say is, it said log 10. This is actually kind of a miscellaneous question. It's not the usual type, but let's see what we can do. Now, log 10 base 8 has been given to you representing x. Okay. Then meaning that if log 10 base 8 is x, that means you can solve and replace log 10 base 8 with x. If you have log 10 base 8, you put x there. That's what I'm trying to say. Then evaluate. He said if you have this, he said you should evaluate what you have, logarithm 5 base 8. He said you do that in terms of x. So in terms of x, you solve it, and then you have your x in your expression. Okay, what we have right now is log 5 base 8. Wow. At this junction, if you are not used to logarithm principles or laws, you may have issues here. Not only that, if you're also used to index, you may have issues here. Now, somebody like, how can I place 5? I can't put 5 in index. There's nothing I can raise to any power to give me 5. Okay, then you're wondering, but what they give to me is to obtain base 8 is equal to x. How can I manipulate this? Now, there are two ways you can manipulate it. Is that you manipulate it by division, or you manipulate it by factors. Ask yourself one question: what can I do? What can I multiply to give me 5? You remember there's nothing. Okay, what can I divide to get 5? There is something. Watch this number here. What do you have here? 10. What can you use to divide 10 to get 5? 2. Yes. When you quickly say, oh, 2 divide 10, 5. Then you start from there. Okay, I think with this now we're good to go. So what you have now is, okay, log 5 is the same thing as saying log 10 over 2 base 8. You have not done anything wrong here. Now, how can I expand this, mind you? In logarithm, once you divide, you expand into subtraction. For example, if I have log 10 base 8 and I'm having log 2 base 8, please go back to the principles of logarithm. What do you see here? Are you not subtracting? Yes. Are they the same base? Same base? Yes, they're the same base. And you're subtracting, of course. Then why did you take log 8? Then when I say this divide is 10 over 2, now this is that you're going to get this back. That means this can be expanded to this. Now, understand this now. I think you're getting it clearer now. So, let's quickly go from here. What do you have? You have log what? Log 10 base 8. Division sign gives you minus. Log what? 2 base 8. It's expanded. But don't quickly forget that in the question, something should replace log 10 base 8. And what is log 10 base 8? According to the question, is x. So at this junction, you bring the x in. So everything here is now x. So x representing this, okay, minus log 2 base 8. Okay, then you are watching again. Is that the final answer? You have already represented this thing in terms of x. There's x now in the expression, but checking it again, this base, can I place base 8 looking at 2 raised to power 7 to get 8? Is it possible? Yes, it is. Because 2 raised to power 3 gives you 8. So continue from there now. So we have x minus log 2 raised to power 3. Okay. And that takes you back to the laws of logarithm. What does it say? It said that when the power of the base sorry, if the base has a power, it goes back to multiply the logarithm, but it is in the reciprocal. That's going to turn upside down. Please hear me. What I'm going to do is this. We have log what? Log 2 raised to the power 3. It will go out, it becomes 1/3 log 2. Alright? So what do you have? Check me please. We have x minus, this is going out because 3/1 is equal to 1/3. Yes. Why am I turning it upside down? Because initially, we normally take our power. I think we still have something on the board. Check it. Now, if you look at this now, this is 2 going as a power here. It's never turned as a fraction. Why? Because it's the power of the logarithm, not of the base. Please come back to this. My point is that this is the power of the base, not the logarithm itself. It will go back to become 1/3 log 2 base 2. At this junction, you know what this means. This is already 1. 1 times give you this. So we have x minus 1/3. This is the expression you are supposed to get in terms of x. If you go check the board, you see that exactly what you have here is what you're having here. There's no discrepancy. There's no difference. Alright? But then, let's just quickly match. We have 2 more questions on the board. I think it's time to wipe this. Please, before me and before you on the board is UTM 2004. Here's the question. So we have to express this to get 3/4. Quickly match it. So what do you say? We have if 6 log logarithm 2 base x minus 3 logarithm 3 base x is equal to logarithm 0.2. Mind you, I omitted something. I think there's 3 there. That's 3 logarithm 0.2 base 5. Okay, so we should find x. Find x. Okay, no problem. This 6, can we do something about it? Of course, it goes as a power, and then not only that, this goes as a power, and then this goes as a power. Let's start quickly. You are used to this now, I believe. So this goes as a power. We have log 2 raised to the power 6 base x. The minus 3 goes as a power. We have log 3 raised to the power 3 base x, and then this goes as a power. You have log, mind you, 0.2 can be a fraction. That's 2/10, which is not 1/5. Are you okay with this? You should. Okay. Now at this junction we have 1/5. Please mind you, I've expressed this to what? So fraction. I don't know if there's someone there watching me. Please, and you are confused about this. All right. Let's go again. That's 2/10. Why? Because if you cross decimal point, put 1 under, put 0 here. There's no number here, so wipe the 0 and the decimal. 2 into 2 is 1. 2 into 5 into 10 is 5. Now you understand. Okay, so we have log 1/5 base 5. Don't forget that we're taking 3 as a power. Put it there. I think at the junction we are good to go. Now express this fact that we have log 2 raised to the power 6. Please, 2 raised to the power 5 gives you 32, and 2 raised to the power 6 gives you 64. Please, if you don't know, please let me teach you like kindergarten. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times 6. Can we go? 2 times 2 is 4, times 2, 8, times 2, 16, times 2, 32. Of course, you have 64. Please understand your index very well. Now we have log, what have you? Log 32, yes, base x minus 3 power 3, 27. Okay, that's easy now, base x. And of course, understand something right now. That's 1/5 expanded. Now 1 cube means 1 times 1 times 1. Why 5 cube means 5 times 5 times 5, which is 125. So what do you have? You have logarithm 1/125. The reason is this: 1 multiplies it 3 times is 1. 5 multiplies it 3 times is 125. Base 5. So at this junction, we can now express this finally to say these two can be joined together, right? So log x here, of course. Open. Because of the subtraction, you divide. 32 divided by 27. This divided is equal to the minus sign. It's equal to log. Now, understand 1/125 is the same thing as saying 125 raised to the power minus 1. And 125 is equal to 5 raised to the power 3 minus 1. When 3 multiply minus 1, you get 5 raised to the power minus 3. I believe you're getting me. Okay, this is what you have now. So here becomes 5 raised to the power minus 3 base 5. So what do? At this junction, we are good to go. So let's see if we can help ourselves here. 32 all over 27. Okay. Is it 27? No, sorry, I was supposed to have 64 here. I believe you get the correction right. We actually talked about 64. Please, I beg your pardon. So we have 2 raised to the power 5 is 32. 2 raised to the power 6 is 64. My error, please. 64 here should be 64. Okay, I think we are good to go. So at this junction, let's see if something can come out of it. Okay, can anything come out of it? Let's see. Now, in this case, we'll do something right now. Let's do something right now. We have a value here. We have a value here. That's logarithm 64 over 27 is x. This minus 3, you know what to do. It's going back as what? Coefficient. And it won't turn upside down. Okay, so go now. Minus 3, come back. That's minus 3 now. Log 5 base 5. Now, rest the case here. It's already 1. 1 times minus 3 is minus 3. That gives you what now? Logarithm 64 over 27 base x is equal to minus 3. Oh, what do you see? What do you see? We're now at the verge of converting this thing to indices. What do you say? X raised to the power minus 3 equal to this. So please don't forget that principle. So let's go again now. Therefore, say x raised to the power minus 3 s power minus 3 equal to this. You are only going to do this when you have logarithm on one side, there's no logarithm on the other side, just a number. Then you can easily convert to indices. Okay? So what do you have now? You have what? This raised to the power this equal to 64 over 27. Of course, you can put this in index form now. 64 now can be placed in index form 4 times 4 times 4. 4 times 4 is 16. 16 times 4, let's go. That's what? 24 carried 2. This will give you what? 64. So you can see that 64 can be placed in index of 4. Okay, so that gives us what? X raised to the power minus 3 is equal to 4 raised to the power 3 of 27 can be what? 3 raised to the power 3. This, we're almost done. Let me wipe this. Well, we have used that. Oh, pardon me, let me come back to this side, please. Let me come back to this side. Let me come back to this side. Okay, here we are. Please travel with me up, please. Now, if you have this, you have this is also a negative value. You can place as, okay, let me rewrite to give you minus 3. And these two carry the same power, power 3, power 3. You can put 4 over 3 in a bracket, put the 3 outside. This can also be placed. How? How do you place it? How do you place it? You can say your value should be what? Should be 1 over s cubed equals to, what have you now? 4 over 3 all cubed. Now at this junction, hear this now. What do we do from here? Now let's say we want to take the cube root of both sides, because it's only cube root that can actually take away this cube. Okay? So what do we do from here? Let's see. Taking cube root of this side, cube root of this side, what do we have? Okay, we say cube root of 1 over x cubed, then we'll take cube root of 4 over 3 all cubed. At this junction, what do we do? Now, what is the cube root of this? Let's separate them. Let me be very clear now. Cube root of 1, cube root of s cubed. Then, not only that, we also have cube root of everything here. Know that this cube will not cancel this cube away. You have 4 over 3. Now let's go. What's the cube root of 1? Means what? 1. So we have 1 here. What's the cube root of this? The cube cancel it away. You have what? X is equal to 4 over 3. Okay, is that the final answer? Not yet. Cross multiply. 4 times give you what? 4x. 4 3 times will give you what? 3. Then another day you have what? X is equal to what? 3 over 4. A little bit long, I just want to make it elaborate. That's what we have here. So permit me now to give you your work I've explained to a great extent. Now you take your own job. Wherever you are, you take this assignment. This is UTME 1992. Okay, I'll bring it up so you see it clearly. UTME 1992. The first question for you today. Okay, and then what is saying up here? It says evaluate log a raised to the power n base b if b itself is equal to a raised to the power 1 over n. Please, you are supposed to arrive at this final value as x is equal to n raised to the power 2. This is the final answer you're supposed to arrive at. Okay, then let me make it 2. Make it 2. You can also take this, said, let's look at this now. If find n number 2, find n if log 4 base 2 plus log 7 base 2, if log 4 base 2 plus log 7 base 2 is an equation that follows, said minus log n base 2 equals to 1. So that's it. That's the value. And this one carries option 10, 14, 27. Option A, 10. B, 14. C, 27. And option D. Finally, we have option D as 28. Okay, so these two will be okay for you for these lectures. And then I believe values has been dispensed and the values has been dished out. This is Turning Point Tutorials. You can always get our videos any day, anytime, anywhere. And I believe that you have paid attention. Please go over these videos and keep learning as you move down to mastery. Thank you for viewing.